Okay. Okay, you're right. Exactly. It's the very top and bottom of Earth. The North Pole, the South Pole. Okay? So your compass points to the North Pole. Those are the polar regions. So they occur near those, but you can still see them from South America, New Zealand, so on. Beautiful. These are normal, regular pictures, not enhanced. Imagine seeing that in the sky. That'd be pretty impressive. Okay, moving on. Auroras. Now, do your best to keep up here. I try to make this as simple as possible, actually. I left out most of the science. Auroras occur from solar wind interacting with the Earth's magnetic field. When solar wind hits the Earth's magnetic field just right, charged particles from the Earth's magnetic field are swept along and accelerated. The visible lights humans can see are the particles being charged and giving off energy in the form of light. Okay, I'm going to define particles and accelerated first because those are the easier ones. So particles are just the smallest units of matter. So we're talking like atoms. We're talking electrons and protons. So if you've ever had science class, just think of the smallest you can get. And they're called particles. It's just one name for them. I hope that makes sense to you guys. But this is all kind of scientific, so don't worry too much. Accelerated, you guys probably do know. Ooh, can't put that there. Accelerated means sped up, okay, so made to go faster. Now, solar wind and magnetic field get a little more complicated, but I'll do my best. Okay, I'll get to that question in 1 second. So solar wind are just particles from the sun, actually, coming towards us. It's like energy from the sun. It's not actual wind, like blowing us, but the sun gives off little particles that go through space. So it gives off more than just light. It's actual particles coming at Earth. And we call it solar wind. It's like all these little particles going along the Earth and everywhere else. Magnetic field is just that. How would you explain that, a magnetic field? It's basically around the Earth is magnetized. That's why the compass works, because it uses magnets, actually. So the whole North Pole, South Pole thing. The Earth actually has magnetic energy, and it has we call it a magnetic field. The actual magnetic activity going on around the Earth. The range of the magnetism, basically. I like that. It's like the range around the Earth. Of magnetism. So there's actually this big force field almost around the Earth that's magnetized. And so the sun's solar wind is bouncing off this thing. Kind of like an atmosphere of magnets, basically. Okay, sweep along. Can we use over here? Like sweep over. Let me look. When solar wind hits the Earth's magnetic field just right, charged particles from the magnetic field are swept along. Well, swept along, swept is past tense of sweep. So we wouldn't say are swept along. It would be swept along. And I have to write that down. I'm not sure if that's what your question is. Can we use over here? You can say, sweep that dirt over here or something, but we're just, swept is just past tense. That's all. It already happened. That's the only difference. Okay. So this one's a little scientific. I hope that made sense to you guys. Let me know if you have any more questions. That's as hard as